Hi everybody, in this video we are going to be creating an echo effect using the line data structure. Now if you're not familiar with the line data structure, I have created a video as sort of an introduction to how that works. I would recommend checking that out, which I'll link above. Obviously we could just use an echo effect. That is something that's built into Sonic Pi, but the purpose of this video is just to kind of explore some interesting ways we can use this line data structure, and this being one of them. And we can also do a few things that we can't necessarily do with just a regular echo effect. So first thing we're going to do is create a live loop that I'm just going to call echo, and we're going to use a sample for this. I'm going to use the electric blip sound, and right now we'll sleep for 0.25. All right, so the idea is we want to hear this sound, and then we want to hear it get kind of quieter and quieter and sort of fade out every time we hear it over a certain number of times. So the way we're going to do that is going to create a data structure, a line data structure. I'm going to make a variable that I'm going to store it in. So we recall the line data structure takes two arguments, or starts with two arguments. So we have a starting point and an ending point, in where the first number we give, so for example, if I did a line 0, 8, it would create a ring of values that are equally distributed between 0 and 8. And it defaults to 4 steps, which is what it would be called. So we get 4 values, but we can also add an additional optional argument here to say how many values we want. So in this case, it would go 0, 1, 2, 3, 4, 5, 6, 7, 8. But the idea is we are creating an echo. So we actually want our first value to be a higher number and our second value to be a lower number. And I'm going to do like 0.1 here. And I'm also going to create a variable called n, which is going to represent the number of values we want in this data structure in this line. So in this case, it's going to be 8, and that's going to be something, a variable we'll kind of want to use in multiple places here. So the idea is that this L is now a ring of values that go from 2 sequentially down to 1 in 8 steps. So we could, just for the sake, puts this here. So here, those values, so it goes from 2 to 1.7625, and you kind of see it just gets lower and lower and lower and lower and quieter there. And you also see it stops at 0.3375 as opposed to the 0.1. So what I'm actually going to do is add one more additional argument, which is the inclusive argument, which means do we want to include this finishing value in the default case. As we see, it does not include that. I actually do want to include it, so I'm going to make that as true. So the next thing within this live loop we're going to do is create a repetition block, so a dot times block, and we're going to go n dot times do and end here. So it is going to iterate the number of steps through our data structure. And then what I'm going to do is I'm going to use the amp option here on the sample, and we're going to do L dot tick. So it's just going to tick through these values here, of which we have basically B2. The value is going to be a little different since we're including this value here, but you see the idea is that the amp, so the volume is going to get quieter and quieter and quieter. I'm going to get rid of that puts, and here we go. So we hear it play through in sort of 8 times patterns, and it sort of starts to get quieter and quieter over that 8 times cycle, and then returns the volume there. So that is a basic idea. So we have that kind of echo effect, and we could play around maybe with these values here. We could put that here. Maybe I want to make that even more. You hear it kind of stops at the end there, which means that value is a little low. And so that's it. That's a basic echo effect. So one thing maybe we could do is we could add some reverb to make it a little, give it a little bit more sort of echoey kind of sound here. So that's one thing we could do. We could also make this a fade in. So could do 0.1 to 2. And then it will start quiet and get loud. Okay, which is not something you can necessarily do with a regular echo effect. We could change the number of times that we want to do it. So I'm actually gonna go back to kind of the fade out here. So now it would be 16 times. You see, we don't have to change this number either. Oh, forgot the comma here. I mean, we could change how fast it goes. So that is one thing we could do, but this gives us the option kind of like a fading in effect or a fading out effect if we want, as we repeat that kind of echo sound. So another thing though we could do is we could play with the ring chain. So remember, a line is going to return a ring that has these equally distributed values, and so we can use the ring chains to kind of manipulate that. If you're unfamiliar with ring chains, I have done a tutorial about that. You can also check them out here in the tutorial section in the help window. They're under data structures and 8.5. So there's all these ways we can kind of add stuff at the end of a ring that will kind of change and return a ring with some manipulated values. What I'm actually going to do here is I'm going to use the mirror, which is going to take the data structure and add a reversed version of it to the end. So what this will do in this case is we're going to hear it fade out, and then it's actually going to fade back in again in that time. So we'll do dot mirror here. And now in this case though, what I want to do is, instead of this n here, because this is actually going to return a value or a data structure twice as long as the number of steps, since we're mirroring it, meaning we're going to get the original version and then the mirror version of that all in one. So for the dot times, I'm actually going to do L dot length dot times do, and that will just be however long this data structure is. So what we should hear now is kind of a fading out effect, and then immediately after a fading back in. And of course we could do the reverse of that, so kind of fading in to fading out if we just reverse these first two values. Okay, maybe another cool thing we could do then is also create a line for pan, so we could actually make it move from one side to the other. In this case, I would do from -1 to 1, and I would do it for, I guess L dot length would be the number of steps I would want it to do that for as well. And then we would dot tick. I'm actually going to create a separate tick here since they're both going on at the same time. So I'll have one tick A and tick B so they don't interfere with each other. All right. So as being even another way we can kind of play around with the line data structure. But that's a basic idea of how you can use this line data structure and create some interesting effects. In this case, that echo effect. But we can not just start from a loud volume and get quiet. We can also play around with starting quiet and getting loud. Or as you see, we can kind of go from loud to quiet to loud again, or quiet to loud. So we can create some interesting kind of sonic scapes playing around with the volume using that line data structure. So find that helpful and able to incorporate that to make some sort of interesting soundscapes in your own work.